Well, it's not working in prod. Indeed, it's not working in prod. Well, it's not my problem. It works just fine on my machine and on the dev server. Well, I told you all systems are ISOs. And if it's working in dev, it's working in prod. It's ISO? Oh, yeah. Essentially, I mean, pretty much almost. Almost? What do you mean, almost? You know, there's maybe a very small gap in minor versions. And for some plugins. Nothing particularly important.
I love that video. It never gets old.
That was great. I've been there. That's not fun.
100%. 100%. Hello, everybody. Thanks for joining us. It is Thursday. Well, mid-morning for me. Hope everybody's doing well in the world. Man, I'm really excited. I have Mr. Kent C. Dodds with us of testing fame. Hello, Kent. How are you?
I'm doing great. How are you?
I'm doing good. I'm doing good. If you wouldn't mind, tell everybody who you are and what you do.
Yeah. So first, elephant in the room. I don't know if maybe you can't tell, but I took a soccer ball to the face last night.
Wow.
We had a really late game, and so if my brain is moving slow, I'm a little tired. And just like bam, I was bloody nose,
Wow.
like a busted blood vessels or something in my eye. But I don't know. It's crazy, but that's not necessarily who I am. So I am a software engineer, do primarily JavaScript stuff, and I am a full-time teacher. I've been doing this for just over 2 years, about 2.5 years now. And I love it. I teach people how to write quality software, and that's how I make the world a better place. I have my own content on epicreact.dev and testingjavascript.com. And then I've got some stuff on egghead.io and front-end masters. And let's see. I'm Google developer expert, really active in open source. I'm married and have 4 kids and a dog, and I live in Utah. And that's about it.
Awesome. Yeah, we were chatting yesterday, and your son was coming in. What, he's 4, 5?
He's 5. He'll be 6 in September.
Yeah, 4 kids. I remember. So I have 7 kids, but my oldest 5 are real close in age. So I remember probably how you are right now. That was like chaos. My younger 2 are a little bit spread out, so get a little bit of breather. But yeah, with 4 or 5 children all together, young, it's just max. You're at max chaos, I can imagine.
Yeah, for sure. Like, it's good to hear that it's not just us. Because sometimes it's just like, is this what life is supposed to be like? Like, I don't have a super great memory of my childhood, like my young childhood, the age my kids are at. Because my oldest just turned 9, and youngest is turning 4 in September. Yeah, I don't really remember what life was like back then, but I'm second to youngest of 12.
Oh, wow.
So I had a huge family, and I remember it being kind of crazy, but being on the parent side of that relationship is very different.
Yeah, 100%. Wow, wait, okay, 12 kids. I have to ask you about the soccer ball injury, but maybe we'll come back to that. 12 children. Yeah, that's so I grew up with 7, same as mine, but yeah, 12 kids. That's a lot.
Yeah, it was.
I think probably though, like, I don't know if I mentioned this. I probably mentioned on the show before, right? But there's like certain number. I think it's around 3. You hit max chaos, right? So like difference between 3 and 12 is just more bodies.
Yeah, So going from 1 to 2 was a pretty big, well, from 0 to 1 is an enormous change, but then 1 to 2 is a pretty big jump. And then 2 to 3 is another big jump because now you're outnumbered. And so one of you has to have 2 of them. And then after that, you're already outnumbered. And so going from 3 to 4 wasn't as big a jump for me.
Yeah. You know what just popped in my mind, and I didn't plan this transition, and maybe it's a horrible transition. But I was thinking about testing, right? Building that first, setting up testing, setting up all, what frameworks you're going to use, what unit testing framework, and those type of things, right? And then you go and writing the first couple tests, right? That's hard. And then you go, okay, this feels good, right? And then you test everything, right? You're doing major amount of tests, and it just becomes chaos, right? Are these tests valuable when they break? Should we just forget them, right? And okay, I'm gonna admit, right? I have failing tests. I can't figure it out. I'm trying to write a feature. I just start turning them off, right? I'm like,
Right, we've all done it.
Right.
Yeah, we got to ship stuff. Yeah.
What's your thoughts around? We were talking about this yesterday. I'd love to get your thoughts right around, how do you think about testing, right? Should we test all of the things, right? Should we only test certain things? And yeah, I love to just get your thoughts on, at least like a perspective of coming into testing, right?
Yeah, sure. So I think that there are a lot of testing zealots out there, people who just think everything needs to be tested always, and if it's not tested, it's not working, and you shouldn't ship it. And then there are people on the other end of the spectrum that think testing is a waste of time. I find myself in between those two. I think that let's keep in perspective what software is for. Why do we write software in the first place? And the reason we write software is to automate things that we couldn't possibly do ourselves, or maybe we could, it would just take a lot longer. And so that's what software is for. It's to automate stuff. So like automate making your budget and keeping track of the numbers, or automate getting your balance in the bank account, or automate, sending a message to millions of people, things that we couldn't actually do practically. And test writing it's software. It's no different. So writing automated tests, that's just software. And the reason that we do it is because, or taking a step back from the automated part, the reason we test is so that things don't break in production, right? When the users are actually using it. That's why we test. Some people write tests as part of their development process. It kind of helps them design the API and stuff, test-driven development, that sort of thing. And I do that sometimes, but most of the time for me, the tests that I run in CI, those are running in CI because I want to be confident that things are still working. And the reason that I don't manually test stuff is because is for the same reason that I don't manually write a letter and send it to hundreds of thousands of people to send a message, right? I tweet, I use software to do that. And that's why we automate our tests so that we can do things practically. And so I have this talk that I gave at Front End Dev Fest recently that is titled Practically Testing, where I talk about different scenarios that you might be in and kind of decide, is it worthwhile to test given this situation? So one example is you're a startup, you're just getting going, you haven't actually sold anything yet, but you just wrote a really complicated function that calculates where a popover should be or something like that. And so like there's some edge cases in there and you're trying to decide if you should test this. And I would say don't bother. You haven't even shipped yet. So don't bother. You don't even know if that feature will exist by the time you ship. And so you may spend all this time figuring out how to test this thing and then delete all of that before you ship, or never actually ship because you spent all your time testing stuff.
Yeah.
And so yeah, I try to be really like thoughtful about the kinds of tests that we write. I think I can say it's a pretty much an absolute mistake to drive for 100% code coverage for most people. There may be some situations like if you're building some heart thing or something like that, yeah, you may want to like test that really well. But for most people, I don't think that 100% code coverage leads to like good solid tests. And so I advise against that sort of thing. Try to be more practical about it, and remember that because testing is just software, it's just another thing that you can spend your time doing. And we need to think about the return on our investment in the different things that we spend our time doing. And so, like, do we get the same return on investment for spending our time testing this thing versus spending our time adding this new feature that the sales team promised the customer or whatever? So we need to like testing doesn't exist for itself. You have to weigh it relative to the other things you can spend your time doing.
Yeah, I love that. That was great. Yeah, and I think that's my thought. So one of my favorite pastimes when we were traveling, go to conferences or just at meetups, right, is asking that question, right, and getting people thinking, right, and I look at it as like an internal debate, right, that yes, we kind of agree as software engineering that yes, we should test, right. You know, and sometimes I'll tease friends, right? When I'll start out saying you should never test, and just as a conversation starter,
See
right?
how they
Yeah, because
react.
people go, what, right? No, you know, but yeah, I think, but it begs the question, right? Well, how much should you test, right? What should we test? How should we think about it? I love that, right? Like the return on investment I heard you talk about, right? You know, is it slowing me down, right? I think I read a study once. It adds maybe 3x to the amount of code you have to write. If you're writing a feature, you have to 3x to test it fully, right? And then
Yeah, I can see that.
yeah, and who knows if that's really accurate or not, but it's definitely more than, you know, just writing the code for sure. And you know, I think my thought process started questioning this when I started writing tests and I'm mocking everything. And it felt like I was testing my mocks.
Yeah.
Right? It was like, you know, it was just, you know, making an API, you know, something. It was just testing my mocks. And I'm like, this doesn't feel right. This isn't, I feel like I'm wasting my time. And it wasn't wasting time, but, you know, yeah, for sure. For sure.
Yeah, you know, this is actually one of the reasons why I created the testing trophy as opposed to the testing pyramid, is because I found that applications, at least UI apps that were primarily focused on the testing pyramid and therefore mostly unit tests, didn't provide a great deal of confidence in the working application. And you ended up having to mock a lot of things. And especially when we're talking about UI, like how far do you go on the mocks? Like, do you mock the entire DOM API? Do you mock React if that's what you're using? So I created the testing trophy to kind of say, hey, maybe the testing pyramid doesn't really apply, at least by the way that I define these terms, which I do have another blog post where I go deep into how I define the terms, which is pretty much any testing conversation you have, you need to first define the terms together, because otherwise you all have different feelings on that. But yeah, so I typically go integration heavy and reduce the number of mocks that I have. And when we're talking about UI, integration tests are typically mocking HTTP calls. So like the world outside of our application, and we're testing the integration of all the components within our app. That's what an integration test is. And so I've found a lot of success in focusing my time and energy on integration tests, and then still plenty of end-to-end and unit tests for those things that are like really like pure functions are the perfect thing that I typically will unit test, and things that have lots of edge cases, then I'll unit test those things. But yeah, I typically try to avoid mocking things too much, because you do end up testing your mocks, and that's not super useful.
Yeah. Cool. Well, cool. Okay. So today we're going to talk about Dockerizing and running tests inside of a container. So Ken has a course, and he has a project that he uses through that. And we thought we'd take a look at that. And I thought I'd walk through containerizing it, running our tests. And then at the end, we'll kind of wrap up with we're not going to do a full end-to-end Docker file with all the bells and whistles. You know, we'll have to go too deep, but I at least want to get our listeners pointed in that direction of how to kind of think about building their Docker file and how to do more multi-stage builds and those type of things. But yeah, so the application is called Bookshelf. And Kent, you want to bring it up? You want to share? And I think Kent walk through the app a little bit.
Here we go. All right.
I'm going to share your screen here. Here we go.
There it is. Boy, you have a really beautiful stream. I love that. So yeah, this is the Bookshelf app. You can go to bookshelf.lol. And actually the app is, because I'm focused on teaching you just the front end, I mock out the entire back end. So there's actually no real back end at all in local storage. So you can go ahead and pull this up, and you can register for an account and everything. So I'll just do that really quick. And I can even tell you my password, because it's all local on my machine anyway. But yeah, so if I go to the Discover page, there are a bunch of books here that I could add to my reading list, and I can mark things as completed and give them ratings, and say this was a great read, and that saves whatever. So it's like it's a typical app, right? And so for testing this, we've got a couple different approaches. So and this is in Epic React .dev. So if you go to Epic React, and I'm logged in, but it is this whole thing right here. This represents, or it's like 100 or 150 videos all right here. Like some of these modules are like huge. There's so much stuff that I teach in this thing, that I use this app to teach, and it's super cool. So yeah, I teach you how to unit test, how to write integration tests, and how to write end-to-end tests. So I'll show you the end-to-end test first. I am using Cypress for the end-to-end test. Super, super happy with Cypress. And yeah, we can just run this test right now, and it will register for an account. It will go through a typical user flow, and just check. I get a silly amount of confidence from this single test, and that's what my end-to-end tests typically are like. It's like let's take a typical user flow, and lots of times, or most of the tests. Sorry, let me say that differently. I will only have one test that actually goes through user registration, and then the rest of the test will just like hit an endpoint, get the cookie or whatever it needs, and then move on. Because you want to avoid over testing, right? So, but in this example, we go through the entire user flow, and we get just a silly amount of confidence out of that. And then the other end of the spectrum is we've got some unit tests. And so here's this use async test that is testing this hook called use async. And yeah, and so this is our unit test. We've got a bunch of different cases that we manage here with this use async test. And then we have our book screen test, which is testing this page right here. So it's rendering the entire app at a route for a particular book with a logged in user. And so then it's adding it to our list, and it's checking it off on our list and stuff. We have various tests for all of those things. So yeah, first we just make sure that it renders all the right information, and we create list item for the book and remove the list item, mark it as read. And we can do notes, and there are different errors that happen. So like if the note update fails, and we show that error message, that sort of thing. And yeah, that's all unit tests. This literally, we render the entire app. Like this is my app component, and I render that whole thing as part of this integration test. And I get confidence in my integration with the router. I get confidence with my integration with the React query, which is making all these queries. A bunch of different things from this this single set of integration tests. And so yeah, I use Cypress for the end-to-end, and Jest for the unit and integration tests. And then there's also the base of the trophy is static tests. And so we have ESLint set up in here. And I'm in the process of migrating all of this to TypeScript as well, which of course I recommend. I haven't in the past. I've decided to not use TypeScript when teaching, just because not everybody knows TypeScript. But now I'm at the point where I'm like, if you don't know TypeScript yet, you really need to learn it. So I'm going to teach you everything with TypeScript, and that's another really important aspect of testing as well. So that's the app.
Awesome. Awesome. I'm going to have to pick a bone with you on TypeScript. No, I'm just kidding. Now that, again, this is another like internal conversation. I agree with you 100%, right? Like, again, how can I argue against types? But can I? Maybe. I don't know. TypeScript.
A lot of people have plenty of, they feel plenty comfortable arguing against types.
Well, my thing is, well, it's not a hard and fast rule or say you shouldn't do this, right? I think you should think deeply about it, like kind of like we were talking about tests, right? I think it kind of, we go into TypeScript and we say, well, yes, of course you need types, and you're gonna perform better, and you're gonna have easier code navigation and less errors and all that stuff. Okay, valid. How long is it going to take you to rewrite your code? You know, if you're starting from scratch, go for it. If you're rewriting, right? If you're going to rewrite a bunch of your app, right? Touching that code and rewrites are hard, right? And they can cause errors, right? And they're going to break a bunch of stuff. And again, I go back to what's your return on investment, right? It is, you're going to spend 2 months rewriting this because the engineers think we need types, or can you slowly do it, right? Do what errors are being caused? What will the actual language help? You know, so
Yeah, I think
yeah.
that's a very measured take on that, and I think that's good. The one thing that I would suggest is that just like when you're migrating, well, anytime you migrate anything, you want to see if you can do it iteratively, and TypeScript is definitely one where you can do it iteratively. The longest time that you will take is configuring the tools, and then as you're making changes, you can slowly migrate. You rename the file and then slowly migrate. So as long as you get your tooling all set up so that it can deal with those file name changes and stuff, then you should be okay. And then the other thing is, I find that TypeScript drastically slows me down when I'm not sure what I'm building. And so I will often just kind of ignore TypeScript, or you can just start in a JS file and do it all. And then when you're ready, then you can move it over to TypeScript. And then one other thing is, it can be really frustrating if you don't know TypeScript very well. And so you end up spending just ridiculous amounts of time figuring out how to type this thing perfectly. If you're a perfectionist like I am, or was when I started learning TypeScript, and then you find out that you don't need the feature and you just delete it, and all that work was kind of wasted. So I advise people to not turn on strict TypeScript rules, and don't be afraid of using unknown or any as you're just getting started, because TypeScript will help you immediately. It absolutely will help you immediately. But it can also slow you down, especially if you're not experienced with TypeScript. So yeah, I think a more measured approach to it is good.
Yeah, 100%, 100%. Yeah, and I would also suggest to folks out there, I meet a lot of folks. Offline, we were talking about and mentor people transitioning from other careers in the software engineering. And and we were talking about learning to read, right? And I kind of think of a pedagogy of a 3-layered approach, right? Where you talk about, you got to learn the grammar, right? So you got to learn a language, right? How the language works, if statements, else statements, types, variables, those type of things. And then you could read, right? Or you can code. And then you kind of have to move up a level, the rung, and do logic. And in logic, meaning understanding how problems are solved, how people solve different problems, and what was their solutions, and how did they work, right? And then I think the next phase is you go into rhetoric, which is argumentation, right? And I think that's where your senior and mostly your principal and your staff engineers work at, right? And they're thinking about those things we're talking about, right? When you're a little bit lower, you go, yes, we need TypeScript, go, right? Or we need test. What? Let's test and test and test, right? And, you know, really should, to progress in your engineering career, at least in my opinion, is you want to get up into that rhetoric as high as possible, where you look down at the different solutions to different problems and see the benefits of each and pull things out of those and create your own argument, let's say, right? And I'm not suggesting you should argue with your teammates or debate, right? It's having good, well thought out
argument. Yeah. Discussion.
Yeah. And so when you have someone like me on your team that goes, oh, well, JavaScript's not types, and why are we doing types, right? You've thought about that, right? You say, well, yes, we're going to approach it this way. And, you know, so I don't know how I got off on that tangent, but that's how I kind of like to think. I think our conversation was hinting at that rhetoric phase, right? I think where engineers should strive to go to. And to get there, you have to understand the JavaScript language. You have to understand there are no types. It's an object language. It's not object oriented. I'm gonna get some heat here on the internet, right?
And technically there are types. They're just not, you don't type them.
Right. Yeah, it's very interesting, right? But it's very powerful, right?
Yeah.
And learning how actual inheritance works in JavaScript, and how the class operator works, and what it's actually doing underneath the hood, right? Where it's different from object-oriented programming, right? And so understanding all those things just makes you a better engineer, I think, better programmer. And then when you go to TypeScript, you understand why you're doing what you're doing, right? I guess that's my point, is make sure you understand what you're doing and not just the shiny new object, right? And you read a blog post, and I think that's exactly what you're saying. So I think we're on the same page. Sorry, we talked earlier. Maybe we'll probably talk forever. But, okay, awesome, man. All right, so we took a look at the app. We took a look at how it functions. We took a lot end-to-end testing, integration testing, unit testing. So I'll share my screen. Let me start taking a look at the app, and let's get this into a container, and then we'll take it from there.
All right, let's do it.
All right, perfect.
And I didn't mention how to run these tests, but you know, and you can show us.
Okay, yeah.
It's simple scripts. You just, once you have it installed and set up, and actually folks who are watching can totally install this right now themselves. So this is part of Epic React, but the whole thing is open source. And so you can go to my GitHub, Kent C. Dodds, and then /bookshelf, and follow the setup instructions. There are like 3 lines that you copy, and you should have the whole thing set up locally. And you can do all of the same stuff yourself if you want.
Yeah, awesome. Oh, what did I change in there? Okay. So yeah, so here's the code. Ken kind of ran down through it, but I'm going to jump down to this Dockerfile. And so we have a Dockerfile in here right now. Don't see anything wrong with it, right? Totally good. There's some things that we can change, that we can refactor. And so let me kind of walk through that. And let me give a quick, just high level overview of Docker containers, images.
And actually, let me also add, as you start that, I am very inexperienced with Docker. I barely can get things working when I'm using Docker. And I didn't actually even make this Docker file. This is a contribution from somebody else. So I don't know whether this is like perfect or whatever, because I know nothing about Docker really.
It's horrible. It's horrible, Ken. I can't believe
I'm on the wrong show.
No, that's totally cool. And that's what we kind of talked about when we were talking about doing a show. I mean, you were very honest. You're like, Docker's not my thing. Container. And I was like, well, I could probably help with that. But the testing. So yeah, perfect, right? And again, this is not bad, right? Not bad isn't the right word, right? It's a good start. There's some things I would change, and then I'm not going to show everything that we should change, right? There's a lot of things you should think about for different places where you're going to run your code, right? So your Dockerfile for production probably will look a lot different than for dev, right?
Yeah.
And it's just the nature of
And how do you typically do that? Do you have a single Docker file and then different like stages, or do you have multiple Docker files, one for dev, one for prod?
Yeah, you can do it both ways, right? Like all great questions, a good answer is it depends,
Yeah.
Yeah, I've done it both, and I go back and forth. I mean, almost weekly, right? Of really trying to get a way of combining my Docker files with my compose files, and how do I get one artifact that I can use everywhere? And it's tough, right? It gets a little complicated. You start to over-engineer things a little bit. So I think do what works best for your team, right? So I'm totally cool with having a Dockerfile.dev, right? And that's your Dockerfile for local. Right. And then
But wait, that cartoon that you had at the start, that sounds like the opposite of what we should be doing with Docker, right? Like we should have the exact same environment for both, right?
Yeah. But they're a little bit different, right? You run them, and it's really the way you're running the process locally. Local dev is a lot different than
you have like watch mode, and you've got like iterative builds, and yeah.
And we're going to take a look at here at the final Docker file. I'm going to try and get folks set up in the direction where you can use one Docker file for everything. I guess my point is don't sweat it, right? It's okay. It's okay if you need 2 Docker files at first, right? Do that, right? Do that. And then I guess with code, I like to do, right? You start coding, right? Top down, and everything's in one file, right? And then you start to refactor, and you look at the commonalities, right? And you see what's cohesive, and put those together, right? And then you decouple things, right? So you make nice, clear interfaces between the two, right? And start to decouple. And I think use that same principles with your Docker files, right? Hey, start with a big nasty Docker file, put everything in there, get it working, and then the commonalities will start to bubble up, and you go, oh. I can move these bits maybe into another phase, or I could take these out, or that type of thing, right? I think that's the way to think about it. And Docker, at Docker, we're trying to solve a lot of these problems, right? Making it easier for developers, working local in containers for development, and simplifying transitioning into the cloud. So we talk a lot about code to cloud, those type of things. We have an integration into AWS, ECS, and Microsoft's Azure ACI, which is Azure Container Instances, and using your compose files to do that, right? And again, it gets a little interesting because the way you run locally with networks and volumes and those things are different than you run in AWS, right? So having kind of overlay files that change your configuration when you're targeting different environments, it starts to break the rule of it runs here but not here, right? I would say,
but the differences are pretty well defined normally, right? Like it's easy to see what the differences are, and maybe, oh, that's why this is happening, because that difference.
I think I really draw the line at dev, right? So anything past dev, it should be the same Docker file. So that's stage, dev integration, prod. We had I forget the environment. We had a business sign-off environment, right? Where before we even went to prod. So I think all of that should be the same. It should be the same Docker file. It should be the same, Kubernetes files, right? That should be all the same.
Yeah.
Running local in dev might be a little bit different. And that's why I'm okay. We'll make that a different Docker file, right? So you are clearly separating that, hey, this is for development and this is for everything else, right?
Yeah. And you can still run the prod version locally too, which is important for debugging and stuff. Yeah.
100%. Yeah. It's like, again, I guess it goes back to our other conversations, right? There's no hard, fast rule, right? Like think a little deeply about it, right? And yeah, awesome. Okay, cool. So let me run down this Docker file. So from the top, so let me back up real quick and talk about Docker and what it is and containers and images. And I'll be brief because I think most people on here should have a good understanding. But since we're talking to developers and we were talking about object-oriented programming, you can think about images and containers as the same ways you can think about classes and objects, right? And instances of that class, right? So an image has everything you need in it to run your application. So it has your application, your executable, your configuration, the base operating files, supporting files, libraries, everything you need to run your app. You put into an image and you build an image by a Docker file, and we'll go down through the Docker file. But a Docker file is basically a set of commands that the output is your image. And an image is nothing more than a zipped up file, a tar file with some metadata in it. It has your file system that process needs to use, the configuration files, everything is inside of that image. And then it has some metadata that tells what process to start and a couple other things.
So is it correct to think of an image like a virtual machine, sort of like, or a description for a virtual machine or something like that?
It's kind of helpful. The way I like to think about virtual machines and containers is, we started out with bare metal. And then we said, hey, we have this big, huge, powerful server and my little web app isn't using all of it. So let me virtualize that hardware and install multiple operating systems on it. So now I have that base metal where I have virtual machines. So each machine thinks it owns all of that hardware, right? So we've virtualized the hardware, got more return on our investment on hardware. And then containers came along, and Docker didn't invent containers, by the way. That the technology was there. They just put some really cool tooling on top of it, raise the abstraction level so we can mere
mortals,
us application developers could use it instead of it didn't need to be Linux, OS developers. And so the VMs virtualized hardware, and then containers virtualize the operating system. So what a container is all it is a normal operating system process that's just been isolated from the rest of the system. So in a sense, it can be thought of as a VM where it's you own, when you think about a VM, you're like, that's mine, right? I own all of it. I do everything on it. Like if you didn't know better, you wouldn't even know that, what kind of server it's running on, how many CPUs it has. You just know I have access to 2 CPUs and I have this much memory. That concept, yes, is the same for containers.
Okay. Yeah, that makes sense. And it doesn't matter what like operating system the container is running on. Within the container, is it like safe to assume that it's just like a Linux operating system?
Yeah, that's the big difference between VMs, right? Is you can only run containers that are built for that operating system. So they they share the underlying operating system. So
so if I build an image on my computer as a Mac and then try to open that image on a Windows, that won't work.
Correct.
Yeah. So they would have to build, they could use the same Dockerfile to build a Windows image of that container.
Right. Right.
Yeah. Cool.
Yeah. Yeah. And yeah, so you have Windows containers and you have Linux containers. And so on your Mac with desktop, if you don't have desktop, Docker desktop, go get it. It runs on Windows, runs on Mac.
I love it. Yeah, it's great.
Yeah. It's the easiest way to get to start working with containers. And on Windows, primarily folks are running Linux containers, right? So they're using their Windows OS to develop in Linux, right? So Node and Java and stuff like that. And what desktop does is it actually creates a little VM, a little Linux VM. And inside of that VM is where Docker Engine is installed. And then we do some fantastic magic, some technology magic through networking to run. You actually run the command line, the CLI outside of that VM, and it talks inside of that VM.
Interesting.
Yeah.
So if I were to build the my image with the Docker desktop app, then I could actually take that image and run it on a Windows machine that is also running the Docker desktop app.
Correct.
Yeah, that's cool.
Yep. Yeah. But to your point, the image is targeted at an operating system, right? And then underneath that at a CPU level or at a target CPU.
Yeah.
Yeah. So if I build a node image on my machine, right, it's going to be targeting Linux. I'm running Mac, so it's going to target Linux. And then if you're running Docker desktop for Windows and you have it to run Windows images, if I send you that image, it won't run. You have to run it as a Linux. Yep. Yeah. So it uses the underlying core operating system of Linux and Windows. And then in Linux, right, then you have a lot of user space and other kind of operating system files, right, that you can switch out between the different distros, right? But the core of Linux, I don't know, get beat up if I don't pronounce it. I'm actually not. I think it's Linux because the creator was Linux.
Yeah, everybody says Linux though. So yeah. People will look at you funny saying Linux, just like they look at you funny when you say GIF.
Yeah, and I think the rest of the world gives us Americans a pass, right? Like we just
can't speak right anyway.
We can't speak right anyway. Yeah. So, but yeah. So that's how it works. So basically, an image is everything tarred up with a little bit of metadata about your application, all your support files, libraries, configuration, and then when you run an image, you run that inside of a container. And what a container is that process, one process. It can be multiple, but only one. You know, the de facto standard is run one process in a container, and so that's an instance of your image running, and you can run multiple instances, and those are containers.
Got it. Okay.
It's one process isolated from the rest of the system.
And then that one process can spawn sub processes, and that's how I can run like a Postgres server and a Redis server and my Node app and all that.
You can, but you'll want to run those separately.
In separate containers. Yeah. Okay. That makes sense. Yeah.
Yeah.
Yep. That's what I do for my site. Yeah.
Yep. Yep. And isolate each one of those processes, and then through networking, connect them.
Yeah.
Yeah.
That makes sense.
Yeah. The recommendation is to only run one, and that's the difference between a VM and a container, right? So a VM, yeah, you have your VM and then you run everything inside that VM, right? Or you could, and that would be okay, right? You might have a background process that's running. You might have your website, those type of things.
Right.
With containers, put those each in their own container and run them. And the idea is if I had everything in one container and, you know, my app fails, right, then my database is going down. Let's say my message queue fails for some reason, everything's going down in that process, right?
Yeah. Yeah.
Yeah. So to break them out into separate containers.
Cool. Well, thank you for answering all my very basic Docker questions.
No, I love it. That's perfect. That's perfect. Okay, awesome. Let me go back to sharing my screen. I'll move this out of the way. Oops. Okay. Okay, so again, you use a Docker file to build your image. I'm gonna refactor this Docker file a tiny bit because I want to talk about some concepts for caching and those type of things. So the first thing, a from command, again, going back to my object-oriented analogy, you have inheritance, right? So you have a base class and then you can inherit from it. So you can use functionality in that base class in your class. Same type of thing here with Docker files. You can use the from command that says, give me a base image, and then I'm going to build on top of that image. So we're going to start here with Node, which is an official image. If I go over to, hub.docker.com. And if I search here, for, not hub, for node, so node will come up. You'll see it's an official image. That tells me that, you know, someone else down here that has a node, Onyx node, you know, these are verified publishers, which a verified publisher says, we say as Docker, hey, Bitnami is, they are actually, this is the real company, and they did publish this image, right? We've verified that. So it gives you a little bit of trust that the content is coming from the source that it says it's coming from. And then, you know, so, you know, secure software supply chains are very important nowadays. Everybody's talking about that, right? You want to know where and who you're getting your software from and what's in it, right? So I would recommend using official images or verified publishers, or know, you know, if it's someone on your team, right? Your infrastructure team, your DevOps team, right? Get your images from them. So I just searched for node, I got the node space official image. And then you can kind of read down through this description and you have a bunch of these tags, right? And so we're looking at from, so the from command says, give me a base image. Node says it's an official image, so we don't have to give a full path to that image. And then the colon delineates how you put a tag on it. So this image is tagged as 16. So if we jump back here and just search for 16, well, the search isn't that great in the browser. Probably find it 16 stretch. Here it is. So 16. So these are saying these tags are all aliases of each other. So 16 and 16-buster, 16.5, 16.5 buster, right? And so what buster is the underlying code name for the release of Ubuntu, which is buster. And stretch is another code name. And you'll have stretch slim, which is a slim version of the stretch release. And then you have a slim version of the buster release, and so forth and so on. And so these are aliases. And so two things here. These are immutable, or they're mutable, excuse me. So they can change, right? So you'll see this one here, latest. So if we don't put anything on, if we just go from node, the default tag is latest, right? And so that will come up here. And right now we're okay because it's the same as 16, right? But once 18 comes out, the latest will now be 18. And if you've tested everything and targeted 16 and you're using the latest tag, well, you're not using the exact image that you thought you were using.
Yeah. Bad news bears.
Yeah, bad news bears. No bueno. Yeah. And it breaks that rule that we're trying to, that problem we're trying to solve, right? It works on my machine, but now it's something happened and it's not working anymore. What happened, right? Or, you know, those type of things. So I recommend doing local development. Again, I think local development is a little bit different. So local development, yeah, go ahead, use latest. You know, use 16 if that works. You know, get a little more specific, 16.5, you know, or buster, right? I like to use the minor version, you know, major.minor version, and then the underlying operating system. More so, not because that it's not going to change, because that shouldn't change, right? That label won't change. The latest changes a lot, but it could, right? But it's just more prescriptive. So if I come into your Docker file and I see node 16.5.buster, I know I have an Ubuntu underlying OS there, right? And I know I have those tools under there. Really, for production, you should start putting an at and then do a SHA, and then you have the SHA at the top. And that goes specifically to that SHA, and that SHA doesn't change, right? It will always pull that image no matter what, right? But we don't need to do that for here. So yeah, so the from command says start with a base image, and then we're going to build on top of it.
What's the best way to find that SHA if I'm getting this set up?
Yeah, you come in here to tags in hub, and then search for the version you want. Let's say buster, and then we have buster slim and then buster. So let's click on buster, and then here's the digest, the SHA right here.
Got it.
And the way you put that on here is you can do an at and then SHA. I believe probably the syntax, I can't remember if colon in there, none. I think it might be a colon. I forget. It might be like that. I forget. But
I
know
can look that up.
yeah, something I have to Google. Yeah, I can't remember off the top of my head for some reason. But I know this works. So we could actually go to the command line here and do a Docker pull. Give it that SHA, fingers crossed, and it's pulling that specific layer down. Right.
Okay, and so this is downloading the. It's not a container. It's the base image, right?
Image, correct.
And that's putting it into my local Docker registry or something.
Correct.
Got it.
Yeah, yeah. It's yeah, the registry is a loaded term, but yes, it's loading it down.
Right.
Docker manages that.
It's like a cache of the registry. Yeah.
Yes. Yes. 100%.
So this is kind of like a global npm install.
Yes.
Yeah.
Yeah. Yeah. So you're doing a npm -g, and then
yeah.
Yep.
Cool.
And now that we have that downloaded, we could do a Docker images, and that'll give us a list of the images. And it's going to be this one right here. And so we could take the other repository, which says node. The tag is off because we use the SHA. And then an image ID is an ID for that local image on your machine. Right. And then we could do a Docker inspect and then give it the ID of that image. Sorry for the fast scrolling, folks. But here's the repo digest. So right there. So 66, let's do 5B43. So 665B43. So cool. That's it right there. And you'll see up here, this, some folks look at this SHA, which is different. That's the ID local. But yeah. All right. Awesome. So that's how you kind of find your official images, your base images. Very powerful. Docker Hub is very powerful to find these components to your application that you want to run. So like Mongo Express, that has Express inside of it. If we just want Mongo.
So can you have multiple base images in a single image?
No, you only have one base image.
Okay, so with the Mongo Express, then I need, is that based on a node image, and then it adds like the Express aspect to it? Like
I'm not 100% sure,
because it's not going to have Mongo and Express and Node running in the same thing. So this is for connecting to a MongoDB that you've got, and you just have an admin interface. So it's going to be based on the Node image base image, and then and they build on top of that to make another image. So you have like multiple levels of inheritance potentially there.
Yes, exactly. And this looks like it's just the admin interface.
Right.
And does it. You might have said that, forgive me. And then you have Mongo running outside, and you can run this Mongo Express app that you can admin. That's probably what you just said. Forgive me. I was reading.
Yeah, you're good. Yeah.
But yes, but you can create a base image and then create another base image on it, and then another, and have multiple inheritance. And that's kind of, so we can go look at this latest, and then let me find, actually it's probably, I'm sorry, this should usually, let's see, there we go. A lot of times in that description, they'll give links into the actual Docker file that builds that image, right? So you can actually go in and read them, and you'll see this one's pulling from node 12 Alpine. Let me go into the node real quick.
And so if I wanted to compose multiple base images into one thing, that's where we use Docker Compose, and we would distribute the Docker Compose YAML so that like I could say, okay, I've got your Mongo over here, and I've got your admin interface, and I've got your Node app, and all of that in the Compose.
Yeah, what Compose does really is instead of starting each container on a command line and doing a Docker run Mongo, Docker run Redis, Docker run, whatever else, and then Docker run my app, you can configure everything inside a Compose file and then do a Docker Compose up. And that will read in all your services, which are basically like images, a configuration set for an image.
Yeah.
So it says node. It says if you're going to build it, work in the current directory, and then set up these volumes and then expose these ports. And then you can do Mongo and do image Mongo latest. And whoops, ports. I think, what is it? 27017? I look right? Is it default?
I don't remember. So the image is, so you can either do an image and that'll go get it from Docker Hub, or you can do build and that will reference the local Docker file.
Correct.
Got it.
Yep.
So if I had a dockerfile.dev, then build would be like .dockerfile.dev, or
yes, we say that again.
Build would be, I guess, /dockerfile.dev.
Yeah,
it's just a path to the Docker file.
Correct. You can give it a context where you want to build, and then I think you actually give it to build the Docker file that you want to use. So you can say, go build this up a directory and use the Docker file there. Yeah, and you can also do an image here. So we can just call it, what is this called? Bookshelf, right?
Yeah.
And so name it, we'll do P McKee bookshelf. And then it'll look first to see if your image is already built locally. And let's say it's 1.0.0. If I have that image, it'll use it. I can also overwrite that and do Docker compose -d, -- build, sorry. And that'll say, hey, go ahead and build the images. Even if you have it, go ahead and build them each time. Yeah, so you can do some different things like that.
Okay, and so when I specify the image, it's going to look on Docker Hub unless I have a build. And then it'll say, oh, okay, I know where to get this. I'm not going to look at Docker Hub.
Correct.
Got it. All right,
Yep.
That's cool.
Yeah, it'll say, yep, oh, I have it. I don't need to go look at Hub. Yeah, perfect. Okay, let's leave that up there. I'm going to take off this SHA just so working directory, this is great. So what a working directory does is it'll create that directory inside of the image if it's not there, and then change directory into it, and that'll become your working directory.
Sure.
Where all subsequent commands will be executed in that image. Yeah, you can think of it as make directory, 2 and symbols, and then cd into that directory. So a lot of times we do make dir app, and then cd in the app.
Yeah, I've got the alias to mg for make and then go.
I like that. Yeah, you do it so often, right?
Yeah.
You'll see old Docker files that'll be like this. Run this command, which is basically a work directory.
Yeah, that makes sense.
So we make a work directory just so it's easier, right? So later on, your commands could be all relative to that work directory, and then later on, you say, I want this to be code and not app, and everything still works farther down, instead of searching down here to find code, stuff like that. I'm going to leave it as code for now.
Sure.
And
so then the copy command, it's copy this first thing to this second place.
Correct.
Within the image. So copy this first thing that's outside of the image to this first to this other place that's inside the image.
Correct. And so we're going to do run npm install. Then I'm going to copy all the files in. So what I'm doing here is like what Kent was saying, is copy the package JSON locally into the image, copy the dash lock into the image. I like to break them out, right? You'll see a lot of like star like this, stuff like that, right? And I just like to break them out just to be explicit. I haven't seen any kind of performance issues or anything like that. Let me get the star out of there. And then after you do that, just like I equate this to just kind of like when you said, hey, Peter, when we were working on this, today's call, you were like, hey, here's the repo. And I go out and I get clone, which basically copies down my, I created a work directory, and then I cloned it, and then I CD'd into it, right? Now I'm in my work directory, right? And then basically the first thing I do is an npm install, especially running with Node or React create React app, those type of things. I'm installing all my packages, right?
Is there a reason that you copy those first? Why don't you just copy everything over and then run the npm install?
Yeah, perfect. The reason being is each one of these each one of these commands are ran in turn, and there's a well, I won't go into the mechanics of it because it's probably changed by now, but so it caches that. So it says, okay, copy package JSON into the image and then cache that. So, and then run the next command and cache that. And you have these layers that are built in the image, and they're built on top of each other. And they're read-only, right? And so it can be cached. So subsequent commands, if down here I did, run move package, if I could spell JSON to, pk.json. This command runs and builds on top of the previous layer. And since I only moved one file, just that one file will live there, and the rest of them will live underneath. And so you kind of layer these changes on top onto these layers. And so each one of these layers can be cached. And
so that way, the next time I build, it's able to say, hey, here's what I had in my container at this time, or in the image at this time. We don't need to do that. We'll just copy that over and then continue on with the rest.
Yes, exactly. And so you move the files that change the most to the farthest into the file.
As late as you can.
Yep.
Okay.
And yeah, so that's why we copy everything over here, because you'll mostly be changing, JS files, right? And so once
that is really useful information.
Yeah, it'll help speed up your subsequent builds. So the first one will take a while, and then if you didn't add anything to your package JSON and just change the JS file, this will be the only command that run, and then everything after it, and then it invalidates every command, every cache,
every command thereafter. Yep. That makes sense. So it's copy is what makes the new layer. Is that right? Yeah,
it's copy on write. There's a couple commands. I can't remember them all off the top of my head, but copy does, run does. I forget what the other ones are. Make work directory does. It's primarily the run and copy, Will.
Okay. Yeah. All right.
Awesome. And the run command just basically says take whatever's after that and run it as a shell command inside, right? We copy in, so you could technically, well, okay, good enough. I don't think we need this in our image right now.
No, yeah. So node setup runs a bunch of scripts that I wrote to make sure that your environment has the right things installed and stuff. And with Docker, you don't have that problem.
Yeah, hopefully, right?
And then it also runs the install command, and then it will run the validate script, which will run all of the linting and the build and the tests to make sure that things were set up properly. So the validate script might still be useful to have run.
Awesome. Yeah, when I first started looking at it, I was like, oh, let me go check this out. I was like, oh, I think because, like you just said, everything is in the image, that we should put it there ahead of time, and then we don't need to do the setup, right? Awesome. Perfect. So I'm gonna delete this, and then we have the command. So command. The command is the only Dockerfile command that is not executed when you build. It's executed when you run.
Yeah, that command always confused me.
Yeah.
So that's good.
Yeah. So this is what gets stuffed into the metadata in your image. So it says, hey, here's your image, and then here's the command you should run when you start this up in the container.
Got it.
And we're using npm start, and I'm sure folks that are on here know that start is inside the scripts in your package, and so it runs react-scripts space start. Awesome. All right, well, let's give this a shot. Let's build and run it. So I'm going to do a Docker build. I'm going to do it a -t, which is a tagging, and I'm going to call it bookshelf. Now we could go and put 0.0.1 something like that. I'm going to leave it off and just do and so it'll default to latest.
In development, you don't really care to make tags. It's only really production that you care.
Yeah, exactly. Yeah, and you'd probably do it. you know, you would do it in your CI, right? And you would have, you know, some kind of system and scripts that keeps track of versioning and
be like a commit SHA or something like that.
Exactly. Exactly. Yeah. I see a lot of folks use a commit SHA for sure. And then this last dot here tells Docker build what context to use, which is basically a directory that you're in. What working directory do you want me to execute this Docker file in?
Right. Yeah. That's mostly useful for that copy command, right?
Exactly. Exactly. Yeah. Perfect. So we'll run this. I think I built it before. And so basically you can see it's.
Oh yeah. Showing the cached work.
Yep.
Yeah.
So we have
now that's interesting. So you changed the working directory to /code from /app. And that was still cached. Is that because you ran this earlier or?
Yeah. Through my testing, running everything, I changed its build, and then so it had a cache for that already.
Okay.
Yeah.
Now, is that a global cache or is that relative to this like path? Or how yeah, I guess where's that cache put?
I'm not 100% sure on that.
Like if you were to clone this in a different directory and then run that Docker file, would it still be cached, I wonder?
I don't believe so. You can't, but you can do some different mounts with caching, and you can say, you know, Docker build kit, don't manage the cache for me and keep it wherever you keep it, but I want you to put it here. And so then I can use that cache across all different builds, across different projects.
Right. That's useful for CI. Yeah.
Exactly. Yeah. So if you're building a bunch of, you know, web services, they're in Node, and you have a bunch of common packages you're using, right? Share that cache, and that'll help build up your, speed up your builds.
Yeah. So for my website, I am working closely with the fly.io team because that's where I'm hosting stuff, and they really want to make it successful because they haven't had a lot of JavaScript folks on Fly yet. And so they basically created a Docker file for me and did a lot of this caching stuff to make it fast. And I can deploy, I build and run all the tests and everything and deploy in like 3 minutes. It's amazing.
Yeah.
So it's magical stuff.
Yeah. Instead of like this locally while we're streaming, this is taking forever.
Yeah. Npm install is not the fastest thing, but we haven't even started building yet. That'll take a sec too. It's all Webpack. So
yeah. All right. If this is hopefully I still have.
Now I noticed that it did. The output did move, but I don't see too much difference in the output. I still see that there is a cached working directory thing. Like, wasn't that printed earlier?
It did. I resized my window.
I thought that a little bit further up it was there too, but yeah, okay, maybe.
No, you might be right. I'm not 100% sure.
Yeah, because I did see some more output. Yeah, there. I don't know. Yeah.
We'll be running. I'm gonna kill this. That's gonna take forever.
Yeah, that's weird that it's taking so long. It shouldn't take quite that long.
No, and it hasn't. It hasn't when I was. There it goes. There, we just canceled.
Yeah, okay. Control C.
If I can spell clear. Let me see if I have it already.
Yeah, you've got
I have
about an hour ago.
Man,
1.9 gigabytes for that little app.
Yeah, I've been kind of ignoring that when I go. So let's see. I don't have node modules local, but yeah, you can do a so you can do a docker ignore.
Okay, yeah.
And you should do node modules.
Oh, that way it doesn't have to copy over node modules.
Yeah. What happens when you don't?
We're installing them anyway.
Exactly.
Would it be beneficial to have the Docker file say if there's already a node modules, just copy that one over instead of installing, or would that?
No, especially if you're on a Linux, that would be okay.
Oh yeah.
Yeah, because your node modules, sometimes it will run like a C compiler in there and compile some stuff for it.
Yeah.
I've ran into that problem, right? I've copied the node modules local from my Mac into an image and then ran it on an EC2 instance, and pulling my hair out, right? Going, why doesn't this? It was like some encryption, utility was not working, and I'm like, what the heck? And And then I realized, oh, you're not, doing an npm. This is many moons ago, right? Like, oh, you're not npm installing inside there. You're just copying everything in.
Yeah.
Yeah.
It was built for something else. Yeah, that makes sense.
Exactly.
Cool. So that could shrink it, and node modules can be quite large. How much overhead is there for I know that there's the slim version of the node image. So apparently there's usefulness in having that exist. So the node image is probably quite large by itself, I imagine.
Yeah. So we can pull, let's just do 16.5-buster. It should be relatively fast. Oh yeah, I already have it. So here's so that's only 900 megs. And then, then we could do probably slim. I'm sure there's a slim.
So it looks like the bookshelf with well, now that's interesting, since we do the npm install, and then before we had the docker ignore, it would actually copy over the node module. So it would overwrite the node modules that we had installed.
Yep.
So yeah, it looks like the bookshelf app is around a gig all by itself.
Yep.
Wow.
Yep. And that could be,
I mean, there's a lot of, if we did this for production, like we ran the build and then we got well, actually, once you run the build, you don't need node modules anymore, because this is not a backend app at all.
Right.
So yeah, it's just to be able to run the build. So we'd have a Docker file for building, and then the output, we would just take those static files and put on a CDN or something.
Exactly.
Yeah,
exactly.
yeah, that makes sense.
And I'll show that here in a minute. So probably Alpine. Let's see if there's an Alpine version.
I think you need a colon.
Oh yeah, well I have to tell it node.
Oh, there you go. I was like, there's got to be a colon in there somewhere.
Yeah, exactly.
Now it's interesting. There are so many things that are downloading and being extracted. Does it come in pieces just to parallelize?
Yeah, those layers I was talking about when you build, those all get cached. Yeah, so if you looked at probably the node Buster and the Buster Slim, will have a bunch of layers that are in common, and then even Alpine will have some layers that are in common, and so it'll reuse those.
I see.
Yeah, and that's why. So like when we first did Buster, we had a bunch of arrows going across, and then Buster Slim we had a little bit more, and then with Alpine, we had like maybe 4 that we're pulling. And yeah, so those are the layers, and they'll get cached and reused.
That's interesting. So are there Docker files just similar? And so it's like, oh, you're doing the same thing, so we can cache that.
Yeah. Yeah.
Huh. Boy, Docker's smart.
Well, our engineers are smart and figured all this stuff out. But you can come into, you can see the layers.
Oh, wow. Yeah.
So these, commands are all, so add this file, which probably is the base Linux kind of support files for stretch, right? So it'll copy those in. It runs some kind of bash command, sets up, adds a user, creates a user with ID 1, sets the node version, right? Starts installing packages and all kinds of stuff, right? And yeah, so you can see each one of the layers. And then with our images, when you push, you can see your layers on top of that, right? Yeah. And there, so I just did the Alpine, and you can see that's 112 megs.
Wow. Yeah, that's interesting.
Yeah, so let's...
I wonder what's so special about Buster that it needs to be so enormous.
It just has...
it's a different OS, right? Like,
yeah, you have OS files in there. You might have curl in there. You might have, zip and tar and, maybe VI, right? Or Vim. Stuff that you probably don't need in prod. So when you go down the prod, you want to get the smallest possible image you can. For 2 reasons. It's easier to move around quickly and start. But that's primarily, you want a small attack surface, right? So if someone does get into your image, if you have curl in there, you have some kind of package manager. I did, there's a DevOps World talk that I gave with Eric Smalling that we're going to be giving coming up. And we talked just about that, right? How you can exploit things that are in a base image, like a curl command, and the
That
package
isn't even needed. Yeah.
Yeah. And you're like, oh, well, I don't have the file I need in there, but I can run commands arbitrarily, and I have package manager. Oh yeah, install this from the web, and then you start going. But yeah, so you want to keep it small. We used to talk about small images size for speed and those type of things. I think
That's for security too.
Security.
Yeah.
Okay, cool. Well,
Sorry, I keep on sidetracking you. We're talking about testing.
No, this is awesome. This is awesome. So let me do the buster. Okay, so yeah, we walked all down through this, but like you said, we want to be able to run our tests, right? I like to do. So let's jump over here. So we take a look in the package JSON, and you kind of ran through this earlier. But you see all these tests, test watch, coverage, debug. Since I'm going to be running this in a container, I don't need to watch it. All right. I might care about the coverage, but not really. I'll probably be running this in a CI process, right? Not too concerned about the coverage. What I really want to do is I want to run my tests, and I want them either to pass, or if they fail, I want to stop building my image, right? I don't want to keep building that image and keep going down the CI pipeline to continue to CD, right? I don't want to deliver that image anywhere. And so what we'll do is we'll do all of our goodness, but before we actually start our app, we're just going to run jest. And I know it's in node modules.bin. I mean, you could do some fancy stuff with, adding an environment variable to path or adding the mode modules to your path. I've seen folks do that up here. We'll overwrite the environment variable with the path and node modules bin, and then put the rest of the path on after it. You can do that. I mean, different ways, whatever works best and the way you do things, but this works fine, right? Run, I want you to execute jest that sits in our bin directory. And again, the run, since it's not a command, which this will get executed. You can't have two of these. So this will get executed when you run the image. We want to run it at build time. Right? So I want to run it when you're building, after you install npm, copy everything in. Then I want you to run my tests. If my tests don't pass, then don't even produce the image, right?
So would there be value if I just wanted to use this to build my app? Would there be value in having a Docker file that doesn't have a command? It just run this, then run this, then run this, and then copy the output to some dist directory or something.
Yes. Yeah.
So that's a thing people do.
Yeah. Yeah. We do it internally. I think we have a blog post. Chris, one of our principal engineers, I think he's actually a senior manager now. Fantastic guy. He did a blog post on Go, right? And they'll build an executable for the different architectures. And then actually the build in the image is only to build it for a certain architecture and then drop out that executable file.
Yeah, that makes sense.
Yeah.
And it's reproducible and heavily cached. That's cool.
Yeah. And you have that build environment. Yep. Sorry, folks. I keep looking over here because I moved Kent onto this other screen. So I'm actually looking at Kent. It probably looks like I'm looking away, but
yeah, you're good.
Yeah, I don't know why our npm is, of course, once you go live, right?
Yeah, during the demo.
Yeah. Anyways, well, let's keep talking while that's running. Hopefully we'll just let it run. Hopefully when we flip back, we'll see tests have passed, right?
Yeah. So if I wanted to use Docker to run my tests in watch mode, would I just have a Docker file where the command is npm tests?
Exactly.
Yeah.
So npm tests. Exactly. Right there.
And then like that. So just watch mode is an interactive shell. And I like once we have the command, do I have all the same interactivity? When in that shell, so anything I type will be sent into the Docker container and
yes.
Cool.
Let me see Docker live stream shell. See the Docker shell. I think let's do Docker run. Let's see what this is running. This will be interesting. It'll be running by now. Okay, so this is running up the React scripts. Start. Wait for it.
And you could do that same thing with the Docker compose command too, because I've got a Docker compose file that that has the ports and everything specified in there.
Yeah.
Cool. So Docker compose is mostly so that I don't have to remember those configurations and I can run multiple at once.
Correct.
Cool.
Correct. Yeah, and it allows you to do things like if we're let's say we had a database with the bookshelf, say Mongo, and I was running them not using compose, I would do a Docker run, -d to run in the background and maybe pass in the password for Mongo and all that good stuff and run that container. And then I would start up my app, right? But since they're isolated, they're not on the same network, so they can't talk to each other. And so then I could create a network. I can do a Docker network create. Then you would name it. And then when you start your images, you would add those. When you start your images in a container, you can add those containers to that same network and then they can talk. And then you're typing out all this stuff, right? And then, but with compose, you can just declaratively do all that and then share that with your teammates and say, here, just do a Docker compose up. It sets up the networking. It runs the proper images, connects them all in the network, and they all just work, right?
And so on my website, I've got a Docker compose that sets up a Postgres and a Redis server, but I run my my app outside of Docker. And so because that's running outside of Docker, I can still communicate with those other two or containers because I'm running outside of Docker, so that I can communicate through my regular network.
Right. Yeah. Cool. To get traffic into the container, you typically publish a port. So you do a -p, and that allow traffic to come in. But you can go out. You can go out from the container, right? So you don't have to publish. You stay on that same port. If you're on 3000, you're doing HTTPS, right? So it'll stay on there. Okay, there we go. It's taking a while. I don't know. Maybe I need a new machine, like we were talking about earlier. Yeah. So this is running inside the container. It's running with that npm start. You can see here I'm hitting localhost. Probably have to register. And now I can discover, add, do all those things, right? And one little thing, let me show you this. So here's where I'm exposing the port. And if I did a -v, which is
volume,
and hopefully it's in code, that'll take my current working directory. Right. PWD is, I call it print working directory. I'm not sure if the P stands for print, but print working directory. And then this will, transform that into a string. Right. And it gives me the fully qualified path. And then says map this from my local machine inside the container in the directory code.
Oh, I see.
Yeah. And so when we start in dev mode here,
you can actually change the files. Okay.
Yeah, and it'll reload for you. And now you're running everything inside that image, that container. You can use the specific node version. You can use all your tools, right? And then you can actually, I could show once we get this in a minute, I can connect into that container and run commands on the command line, see all the files. A lot of folks do it. I do a lot of this myself, right? I'll create a base image that is my dev image, and I'll run that up, but I'll start as the command is just a bash. And so I'll run that image inside of a container, and then I run it with interactive mode with the -it. And then, so that drops me right into a bash shell right inside my container. And then I can do npm start there. I can do everything.
Okay.
Yeah.
Yeah.
Yeah. It makes it easy,
and then you could do, you could run your tests. You could basically do all the things that I normally do, just within a container, completely reproducible environment.
Right. Yep. Exactly.
Yeah, that's interesting.
Yeah,
and you could set that up in Docker Compose too. So just as another one of your services. So then when you're telling people to set up your project, you just say, we just have a Docker Compose. Just, do a clone and then Docker Compose up. And then, you're set. And so with Docker Compose, can I have an interactive mode on one of those services?
Yeah, you can tell to go into interactive mode. Yep.
Okay, but you'd only be able to do that for one, right? You can't have multiple interactive mode.
No, you can do both. You can do them all.
Really? So how do you, because you only have one terminal that you're running this in, so how can you be interactive with multiple services?
Yeah, my apologies. You can execute it and connect to one of those images. Yeah, so they'll all be started, right? Usually what I do is put them in, do a -d, so Docker Compose up with the -d and put them in as daemons or whatever, running in the background, and then exec into each one of them.
Got it.
That's probably the proper, better way to do it with Compose is, start them all up so you don't have to type everything out, and then exec in and grab the bash shell right inside of each one of them.
Yeah. Well, if there was only one that you ever cared to bash into, like the app itself, then maybe it would be okay to have that interactive mode for that one, so that you just Docker Compose and then you're off. Although, like, I don't typically like to shut down my Postgres and Redis database as I'm working, right? Like I would for my app. Yeah, something to think about. That's interesting.
Yeah. And it kind of goes back to our earlier discussion at the beginning, right? There's local dev is very unique, right? Because you can do it in all kinds of different scenarios, right? Do I want to fire everything up Compose? Do I want to put one in interactive mode? Or do I want the one image where I'm working in, do I want to use my base dev image and not an image that I built? And then I'm going to use a volume to, I'm going to mount my code into it. Right. And then use Mongo and let's say other web services, right? You're on a team and you're the UI person, right? You might not even run your React app in a container, but you can run Compose and fire up all your dependent services with Compose. You can build some locally. You could pull images down from Hub, from your team's repo. There's all kinds of different ways to do it.
Things. Yeah, it's interesting.
All right, I'm going to try and live change something here. Peter's reading list. Oh,
rats! I wasn't happy with that.
Did I map it in? Can't remember if I mapped it in.
Yeah, I can't remember on that one if that one was mapped or not. I think it was.
Let's do this. Let's do Docker PS will show me what's running. So there's my image right here, and the name of it is Bookshelf. So, oh my goodness. I probably just lost. No. Okay, so I can do Docker exec into Bookshelf, and then we'll do bash. Okay, so now I'm inside of that container. That was the problem. See, it's in app. So on my
right, code, and you said map it to code. Yeah,
map it to code. So if I bet you go to code,
there it is.
There's the code too.
All right.
And what was that file? Authenticated.
So now the Docker file actually will copy everything to the /code directory. And so if you say I want to mount this volume to this local thing, does it just skip that step, or does it overwrite the code directory with what?
Yeah, it'll overwrite it.
Okay.
Yeah.
Cool. And because it's mapped, it's basically pointing directly to it. So if I change files and everything.
Exactly.
Yeah.
Yep.
Cool.
Yeah, and you can be careful, right? Like if node modules are interesting, right? If you're mapping the node modules into your container, they're huge, and you start installing stuff locally, and it could take a while. But then on
is it actually copying things over as files change or something?
Yeah, I'm not sure exactly. Yeah, I think it copies them because it's actually inside of a VM. And if your file system is outside of that, sorry for hitting the mic, and then inside the VM, it'll copy your files back and forth, right? You can mount volumes and stuff like that, read only, those type of things. So it's just, one-way copy, right? And by the way, don't do, we call them, those are bind mounts, right? don't bind mount when you run in production. You want to use volumes or, you know, some other construct. Totally. Again, it's always this dev is a little bit different than everywhere else, but locally it's fine. But yeah, it'll copy things over. Sometimes you can get performance issues. The team at the desktop team is really, really improved it a lot. But if
you're
really
changing tons of files and like npm install and stuff like that, then
yeah,
that can be slow. Okay.
Yeah. Yeah.
So you want to run the npm install from within the container rather than
that's my thought. Yeah. Yeah. So if I would have started this image correctly, yeah, we set it in the code, so should be an app. Oh wow, we're at 12:30. I probably missed the meeting.
Sorry, I'm a talker. I'm a question asker.
Well, cool. Okay, so let me run through this real quick. So this will run our nodes. Just you know, and I deleted my local node modules, didn't I?
That's all right. I think most people should be able to get what's going on.
Yeah, they'll understand. Yeah. So that's just running that'll execute your test. If it fails, your image will stop building. Right?
Build failed.
Yeah. And I'm going to get down to let me jump ahead and show kind of where we kind of go with some of this. And kind of your original comment, right? Like, hey, how do you know, let's keep one base Docker file, right? And as you can see, this is a relatively simple one, and it starts to get complex, right? And that's why I'm okay with, if you want to have a dockerfile.dev, totally cool, right? Because then that's specifically for dev. I would say though, keep one other Dockerfile for everywhere else you're going to run, right? You could even keep, you know, a .dev file locally, like put it in your ignore, you know, get ignore, and then just have people use it, or have a Dockerfile.dev. You know, what do you do? You do this with environment variables, .environment. Well, there we go. .development type thing, right? Or you know, you check in a .environment variable file into Git, but you don't have values in there, so everybody just knows, oh, okay, I need to plug these in to run it local or whatever. Yeah, kind of the same concept, but so here this Dockerfile is using multi-stage builds, and what that is again, it's kind of that inheritance, right? But you can do it within one Dockerfile. So at the top here, I create a base image, labeled as base, right? And that image is coming from node 6.5 Buster, just as before. And I'm going to label this image that's going to be built from here as base. Set up a working directory just as before, packages, copy in, run an npm install, and then copy the files in. Now we got npm install, and we got all of our source code inside the image. And then depending on what I want to do, so do I want to develop? Then okay, then I'm going to build the image. Where's my command line? So when I build
how do you specify which one of these things you want to actually build? That's
right.
Target. Okay, so target is the name, like the alias, or the label that you used. Okay.
Yep.
Cool.
And so when we run that, I'll let that run and see. Did not be found. Oh, probably need this. Always helps to save.
Yeah.
We'll let that guy run.
And so then it's gonna say, oh, you're copying this from base. So let me go see what base is. All right, that's getting it from node. So we'll do all of that stuff.
100%. Yes.
Yeah.
Perfect. Yep.
And then I could run this. I could run this in multiple tabs. I could run dev here and then test over here, and they're both using like the same base image as well. So they get all the same caching and everything, but they're in isolated environments still.
Correct.
Yeah, that's interesting.
Yep. And then down here we have the web server where I'm using Nginx, labeling as prod, and now I'm using that from this -- from for my copy command, or using the -- from with my copy command, and I'm saying copy, you know, everything in code, build, and put it into user share Nginx HTML. This is the default location where Nginx will look for static files. But don't copy this from this image. We don't have a code build here, but look at build. right? So that looks at build and goes, oh, well, that's based on base, right? Like you said, so it goes up to base. Oh, code, that's where all my source is at.
Cool. Yeah, that makes sense.
And we'll copy it in. Yeah, actually, this I pulled from another place. We'd want to do, oh, no, I'm sorry.
Yeah, we want the post build.
My apologies. Yeah, it'll look at build and then go all the way up, and then it'll run, make sure it runs this. So you run the npm build, then it will execute this. Yep. Cool. Yeah, and so that, and then only your Nginx Alpine, only this image will be exported, right? So you'll have a nice small image. All these, since we targeted prod, all these intermediate images will go away. They'll be cached. But
so if I ran this in like GitHub Actions or something, I could run the whole. Basically, all I would. Yeah. So I would run the. Yeah. What would I do? Would I run the build, and that would take care of, getting node and all of that stuff. And then I would send my Docker file up to prod and just say run prod. And here is. Yeah, what would happen if I sent the Docker file to prod? Like, could I send all the built files along with it, or how does that work?
Yeah, I would.
I don't want to like actually run the build on the prod server, I guess.
Yeah, I would run it in your GitHub action. I would probably run tests first. I would have a and I forget what they are in GitHub Actions. They steps in
the
there.
Step,
yeah, step. I'd run the test, right, and then say don't go to the next step unless that's passed. So if that passed, it'll produce an image, and then you don't push it anywhere. It'll just leave it, and then okay, cool, that's passed. Then build my production image, right, and then have another step that either pushes the hub, right?
Right. Yeah, because just because you built the image doesn't mean it runs the command. That's right. Yeah. So you build that production image, and then that's what you send, and that will have all of the built files in it. Right. That makes sense.
Yep. And then your CD bits pick up and go, oh, I have a new image. Let me pull that down. Let me update my cluster and rolling updates or blue-green, whatever, however you're doing CD, which is the hardest bits of CI/CD, if you ask me.
Yeah, this is why we pay other people to do that stuff.
Exactly. I do not know what's going on with that. I swear this morning I ran all these demos, my npm install. Of course, it's because I'm live streaming.
No, well, it's a good thing that you did, because we were able to see a bunch of the other stuff. So I'm not worried. I know it works.
Awesome. Yeah, a little bit of my my whatever it is, my psychosis is like, people aren't going to believe it really ran.
Well, that was really informative. Yeah. That taught me a lot of interesting things I'll probably use. I need to think more about running my entire dev environment in Docker. There are definitely benefits to that. And when I upgrade to Epic React, I'm planning on having like a real backend. The bookshelf just puts everything in local storage, but I think it'd be really useful to have a real backend. And so for that, I'm going to use Docker. And so I just need to think about like what's the easiest way to get people up and running, and maybe having the entire dev environment in a Docker container would just make that the easiest.
Yeah. I mean, it's, we're weird, right? We're an interesting bunch, right? It's like, I try and equate it to being a carpenter, right? If I'm a carpenter, I'm a master carpenter or a mason, right? I have my tools that I use, and I have them in my tool belt where I want them, right? And I have my hammer that I've had forever that has that little notch that's been worn out in it. My grip is just perfect, right? And so, and then I go work at a construction company and I say, Peter, that's fantastic, but here's our tools that you need to use, right? It's a little bit harder, right? And I think that's how we think about it as devs, right? We have our stuff. We have our local machine. We have, the color combinations in the terminal the way we want them. We have, all this stuff set up exactly how, our command line completions and blah, 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 all this stuff, right? And then if you start putting things into a generic dev environment, sharing that out, that becomes, it's like saying, hey, Peter, don't use your hammer. I want you to use mine. And you're like, but it's not the same. And you're like, well, it is. It puts nails in the wood. And you're like, yeah, I get that, right? And so but it's not, right? So that's, I think, and we're talking about that internally here. And I think we talked about it offline when we first started chatting, right? It's like, but there's a lot of benefit to putting everything into an environment that's the same across machines, teammates, right? Those type of things, right, is very, very useful at the same time, right? So, yeah, like, and sorry, yeah, we're way over time, but that's how I kind of think of dev environments in the cloud, right? Like, yeah, you go, oh yeah, I hit a GitHub button, boom, and I have a cloud IDE and I'm working on the project, right? It's like, yeah, it's never that easy. It's never that simple, right? It's never that simple, right? Awesome. Well, I really, really appreciate it. We should continue the conversation. I loved having you on, man. You had some great questions. That was awesome. That was really
Thank you, Peter. This was really awesome, informative. Hopefully the people watching got a lot out of it too. And I appreciate you giving me some time teaching me Docker.
Yeah. And everybody go check out testingjavascript.com. Is that a good place to go?
Yeah. Yep. Testing JavaScript if you want to learn testing JavaScript, and epicreact.dev if you want to learn React.
epicreact.dev. And I'll put those in the show notes so people can check them out.
Cool.
Make sure you join our community. Go to /Docker-community. Join our community Slack. All of our engineers are in there, our PMs. A lot of our execs are in there. So if you want to interact with Docker, go there. And the community is huge. Captains are in there. They can help you out with issues you might be having. And the second thing I want to point out is go to our roadmap. That is our public roadmap. Again, Docker uses that, it's just not a facade. It's our real roadmap. Those are the things we're working on. It's a way to help direct Docker's direction, right? If you are a developer and you're thinking about working locally, you're thinking about containers, how can they help me, right? Reach out to me, in the Slack. Love to hear how you're trying to work local, how Docker's getting in the way, how it could work better, right? Like, we're really trying to help developers get more productive and focus on, writing code and not the other stuff, right? Awesome, man. Well, again, really appreciate it. Thanks for coming on our show.
Yeah, absolutely.
Yeah. And thanks everybody for joining us. And we'll see you again next week, next Thursday.
Bye.
Cheers, y'all.